Welcome to The Explainer. Today, we're unpacking India's newest, and honestly, arguably its most fascinating milestone in space tech so far. We are talking about GalaxEye's Mission Drishti. This isn't just another satellite launch. We are looking at a fundamental shift in how we actually observe our planet from orbit. We're moving straight from prototypes to highly scalable commercial intelligence.
So here is our roadmap for today. We'll start with Mission Drishti's launch, break down the OptoSAR technology, look at their in-orbit AI processing, explore the defense and dual-use demand, and finally check out how they plan to scale up their satellite constellation. Let's dive in. I want you to imagine giving a satellite superpower vision. Seriously, what if it was completely unaffected by adverse weather, thick smoke from wildfires, or even just the time of day? For decades, satellite imagery has been hard-bound by the basic limits of physics and weather. But as you'll see today, that era is pretty much coming to a close. All right, let's kick things off with Section 1, Mission Drishti takes flight. Just this past Sunday, riding on a SpaceX Falcon-9 rocket out of Vandenberg, California, Mission Drishti went into orbit. Now, it weighs in at 190 kilograms, which officially makes it India's largest privately developed Earth observation satellite. And that weight class, it's absolutely crucial. It allows them to carry an incredibly robust suite of instruments, pushing way past the limitations of those smaller, simpler nanosatellites we see so often. What's wild is how they built this thing. This Bangalore-based startup, which actually spun out of IIT Madras, managed to pack a massive 3.5-meter deployable antenna into a spacecraft roughly the size of your kitchen fridge. And they definitely didn't just cross their fingers and hope for the best on launch day. They strapped this payload to drones and Cessna aircraft for over 500 test flights. Plus, they ran an earlier trial on ISRO's PSLV POEM platform. Talk about doing your homework. Okay, moving on to Section 2, the OptoSAR breakthrough. This is where it gets really interesting. So for a long time, the space industry faced a brutal trade-off. On one hand, you have electro-optical sensors. These give you beautiful, crystal-clear photos, but a simple rain cloud completely blinds them. On the other hand, you have synthetic aperture radar, or SAR. SAR sees through any weather, day or night, no problem. But the catch? Radar data looks like a static-filled mass that's incredibly hard for the average user to decipher. Well, GalaxEye basically refused to choose between the two. They created OptoSAR, which is literally the world's first technology to physically integrate and synchronize both of these sensors on a single platform. By fusing them together into what they call sync-fused OptoSAR, they are generating up to 3 times more usable information than a standard satellite. It's a total game changer. What this means in practice is consistent, sharp, and highly reliable data of global locations every week to 10 days, entirely free from weather constraints. We're talking 1.5-meter resolution here. That is sharp enough to easily spot individual vehicles on the ground. And the best part? You can trust that that data will be there, whether it's a perfect sunny Tuesday or the middle of a midnight hurricane. Now let's look at Section 3, AI processing in orbit. Capturing all that incredible data is really only half the battle. Typically, satellites have to beam massive, clunky raw files all the way back to Earth, where massive server farms crunch the numbers. Instead, Mission Drishti uses NVIDIA's Jetson Orin computing platform to perform edge computing directly in orbit. So they've essentially strapped a high-powered AI brain right onto the satellite itself. The workflow here is just so streamlined. Step 1, capture the raw dual sensor imagery. Step 2, process it immediately right there in orbit using NVIDIA AI. And Step 3, beam down only the finished, actionable intelligence. It practically eliminates that massive data bottleneck we usually see, getting vital answers to decision-makers on the ground in record time. Which brings us to Section 4, defense and dual-use demand. Who actually needs this? So who is clamoring for this rapid, weatherproof data? Well, while OptoSAR is a dual-use technology, roughly 70 to 75% of the early interest is heavily anchored by defense and security sectors. And it makes sense, right? Amid rising global geopolitical tensions, security agencies simply cannot afford to sit around and wait for clouds to clear to see what's happening on the ground. But beyond defense, the civilian impact is truly immense. Think about disaster response for a second. Rescue teams can assess damage from floods, cyclones, or landslides instantly. They can get this data while the storm that caused the disaster is literally still raging and blinding traditional optical satellites. Plus, it opens up incredible efficiencies for things like agriculture monitoring, infrastructure planning, and making super precise insurance assessments. All of this wide-ranging utility is fueling massive market momentum. The global satellite-based Earth observation market is currently sitting at an estimated $4.3 billion for 2025. But to put things into perspective, it's projected to surge to $6.3 billion by 2030. That growth is driven heavily by commercial needs, like ESG reporting, supply chain tracking, and climate risk analysis. All of these require the exact kind of uninterrupted data that GalaxEye is providing.
All right, let's wrap up with Section 5, Scaling the Space Constellation. GalaxEye is moving incredibly fast. Following that Sunday launch, they have an aggressive window of just 8 weeks to begin their commercial data rollout. And once they validate this data quality, they are not stopping. They plan to rapidly deploy a full constellation of 8 to 12 satellites over the next 2.5 to 4 years, which will make their global revisit times even faster. To fuel this massive global engine, they're prioritizing distribution across the US, West Asia, Africa, and Europe. And they've definitely got the war chest to pull it off. They're backed by $18.8 million in funding from heavy hitters like Infosys, Mela Ventures, Special A Invest, and Zeroda's Rainmatter. On top of that, they've wisely secured a global distribution partnership with New Space India Limited. CEO Suyash Singh sums up their whole strategy perfectly. He says, "We are not trying to chase governments and ask what they want us to build. We believe this is a differentiated data set that can serve both defense and commercial users." They aren't just sitting around reacting to requests. They've architected a fundamentally unique data set that changes the industry standard for literally everyone. Which brings us to our ultimate question for you to chew on. How will real-time, weatherproof intelligence from space rewrite the rules of global security and climate response? Because when a lack of visibility is no longer a valid excuse, the way we manage our entire planet fundamentally changes. Thanks so much for joining us for this explainer, and we will see you next time.